proposal for the presentation. By the time we got to about here, it was pretty obvious that actually 2023 is the year of large language models and ChatGPT. But all's not lost. Towards the end of the session, I will show you how we can embed or we can integrate with Llama, which is Meta's open source large language model using WebAssembly web services on the back end. And for those of you who don't know InMyData as a company, we used to be Data PA, we do analytics software. In the last few months, we've been embedding ChatGPT into our analytics product, of course using WebAssembly as the front-end architecture. So I'll show you a little bit about how we've done that in terms of using WebAssembly for the front end. And actually, regardless of all the developments that we've seen with ChatGPT and large language models, I think it's widely accepted that WebAssembly is one of the most significant developments in application architecture that we've seen for decades. And really, if you're involved in application architecture, you should understand it. You probably should be using it, and it's certainly significant. So what is WebAssembly? If you've not come across it before, if you've never used it before, it started off as a pet project of a guy, Alan Zakai, to try and get games running in the browser. So he was trying to compile C, C++ code for frameworks like Unity and Unreal and get them running in the browser. And initially he started off in 2010 trying to compile them to JavaScript because that was the only technology that you could compile to in a browser. I've told this story a few times actually in talks like this and blogs and stuff like that. It still astounds me that you could get something like Unreal running on top of JavaScript, but he managed it and they successfully got games running on top of it. But it was quite clear that that's not really the best technical way of running that sort of code in the browser. And really what you needed was a virtual machine inside the browser. So instead of compiling to JavaScript, which is an interpreted language, you could compile to machine code and run that within a virtual machine. At the time, he was working for Mozilla. And at Mozilla, they decided to try and design this virtual machine that could run inside the Firefox browser. The guys behind Chrome were doing something very similar at the same time, and luckily for us, they started working together, and by 2017, that's exactly what we had. So today, you can take any of 70 different languages and compile them to WebAssembly. So WebAssembly itself is machine code. WebAssembly is just a readable representation of the machine code. And we have a virtual machine that sits inside the browser that can execute that code for you. And it sits alongside our traditional technologies within the browser. So today, WebAssembly is the 4th web standard. It's been adopted by the Web Standards Agency and sits alongside HTML, which is our presentation language, CSS, which is our, HTML, which is our markup language, so we can define what's on the page, CSS, our presentation language, so we can define how it looks, and JavaScript, our behavioral language, so we can define behavior. So a good question is, why would we want this 4th web standard? Well, think back to what we were talking about originally, about Alan Zakai trying to get games running in the web. And that's really where it came from and one of the key reasons for using WebAssembly today. And that's if you want to take existing technologies and port them to the web. So if you take Adobe, for example, Adobe want to distribute their design software through the cloud. It's almost impossible for them to get something like Photoshop working for JavaScript. It's just not efficient enough. Their code's all written in C. Trying to target JavaScript for C would never give them the performance they need. But today, if you go to photoshop.adobe.com, it'll download and run Photoshop in the browser for you. And it's fully functional. It's got everything that you've got in Photoshop on the desktop. So for instance, I can take, where's it gone? Oh, well, let's take this picture. So you can take a picture like that and you can say, okay, let's just blur the background in it or make any changes to it. So something like blurring the background, that's a bad example. I did have a picture that worked perfectly for this, but it's not offering me. Let's try, oh, there it is there. So this is a photograph of my brother-in-law and nephew on a bike ride in the Southern Upland Way up in Scotland. And it's a great picture, but the background's really busy. So maybe what we want to do is just say, okay, let's blur the background on the picture. And you can see there's some AI that recognizes what's in the picture, and I could turn the background black and white as well. And that really makes the two guys and the bikes that they're sitting on stand out. So there's a lot going on there, but the key thing is just look at the performance of it. It's exactly the same performance that you'd get on the desktop. And there's no way you could do that without WebAssembly, and that's the real key advantage of WebAssembly is you can take that existing code base. So Photoshop took their existing Adobe took their existing Photoshop code and just recompiled it through something called Mscripton, a tool set to compile to WebAssembly, and then stuck a web skin on the front of Photoshop, and there it is running in the web. But it's about more than just performance. So we've talked about taking existing applications, so games engines like Unity and Unreal have been compiled to WebAssembly. So now any games that were built on those platforms can be run in the browser. Pick a Voice is a great example. So Python is one of the languages that you can compile to WebAssembly. Most of the machine learning and AI developments that have happened in the last few years have happened within Python libraries. So Pick a Voice took the speech-to-text Python libraries, compiled them to WebAssembly, and now offer them as a component library for your web apps. The beauty of it is, if you want to add speech recognition into your web app, you can do that in the browser. You don't have to record the voice, send it to the server, process it on the server, and send it back with all the privacy issues that entails. You can do that processing in the browser on the client machine. And then Blazor. Blazor is Microsoft's port of .NET to WebAssembly, and it allows you to create apps with C# on the front end and C# on the back end. And that's what we've used developing in my data. So I'll show you a real-world example. Our app, the whole front end, is built on WebAssembly, so we've got C# back end and front end. And 4 months ago, like everybody else, we were watching the news about ChatGPT and thought, well, hey, this would be a great thing to add into our analytics platform so our customers could talk, have conversations about their data. So if I show you first what the interface looks like. So once we've logged in, we can open charts, we can go and create charts, we can view different visualizations of the data, or we can just go into a chat interface and start talking with our data. So if I had a dashboard open here, I could go and select the data behind those dashboards, or I can just select predefined the data sets that we've got in the platform. So in here, we've got a retail data set with 1.3 million rows of data in it. And maybe I want to know, give me the top 10 stores based on sales in the 7 days. And I need the speech to text bit in there as well. 7 days up to and including last Sunday. And it'll chug away. So that's going off and looking for what data that it needs, and having a conversation with ChatGPT to get the answers back. What I want you to look at is the different types of messages that we've got in the message chat. So when the AI is talking, it looks like the AI is typing itself. We just downloaded a component to do that. There was already something written in Blazor that we could just do for that. We've got a chat session, and we've got different types of messages in that chat session. We've got thoughts at the top. We've got responses. These are actually canned responses, so I can't give a thumbs up or thumbs down to them. We've got other thoughts, and then down the bottom, eventually, when it comes back with the answer, we'll have a response where I can give it a thumbs up or a thumbs down. While it's thinking about that, we'll go and have a wee look at the code behind it. So the first thing that we needed to do was we needed to define a model for those messages to go backwards and forwards. So this is my AI chat message model. We can see we've got the different types of message type in there: questions, thoughts, response, canned messages. I've got the text of the message. I've got a rating. When it comes back, it'll give me a chart. So I've got a dashboard object, which is the chart, and then we've got some other functionality in there. So that's my model. The advantage of us using WebAssembly, or Blazor in particular, is that this is my page. So this was the chat page we were looking at. If you've used WebSpeed before, you'll be familiar with this type of idea where you've got markup and then bits of code in the markup. In WebSpeed, it would have been ABL. Using Blazor, it's C#. So you can see I've got some divs defined here. I've got a little if statement. And then down the bottom, I'm saying if I've got a current chat session here, and then a for each on the chat session, and then I'm just got a load of if else statements to say what type of message it is, and then I've got the markup that relates to that particular message. The beauty from our point of view using Blazor is, whereas previously we had a JavaScript front end and a .NET back end, we would have had to build that message model in JavaScript and that message model in C#, and then we'd have had to have a load of conversion between the two. Whereas in Blazor, this is the back-end code that actually gets the session out of the database, and you can see down here, it's creating one of those AI chat message objects. So in terms of productivity for us, it takes a lot of work out of that back-end and front-end communication. We're using the same language, the same model. We can put functionality that's available in both, on both sides. So it's really improved the speed at which we can, and there we go. Finally, we've got the answer. We can click on it, and it'll show us a chart. Oops. As everybody knows with ChatGPT, sometimes it makes mistakes. So we got the filter slightly wrong on the chart. But anyway, there's the example. So from a productivity standpoint for us, using Blazor makes a huge difference. However, most of the developments that have gone on in the WebAssembly world over the last few years haven't been anything to do with the browser. It's all about what's going on in cloud architecture and cloud solutions. So all of the advantages of WebAssembly in the browser happen to be really advantageous to us when we're deploying cloud infrastructure. So it's flexible. We can compile over 70 different languages and all of the libraries that are in all of those languages to WebAssembly. Obviously, that's important when we're building server-side architecture. It's fast. It was built as a virtual machine from the ground up, spins up really quickly, and when you run code through it, we saw with that Photoshop example, it runs at near native speeds. So you're paying less for the compute power in the cloud. It's portable. We'll talk about this a lot more, but it really is a scenario where you compile it once and run it anywhere. And obviously that's something that's important in the cloud environment, and secure. It was designed to run inside the browser first. So it's designed not to be able to natively interact with any other app that's running on that machine or the operating system itself. And obviously when we're running things in a cloud environment, we're sharing architecture. We don't want it to interfere with other people's apps or the machine that it's sitting on. So all of those things that were really advantages in the browser make it really, really usable and compelling as an architecture to use for cloud architecture. And so in 2019, the Bytecode Alliance, which is the group of large companies that oversee developments in WebAssemblies, companies like Microsoft, Google, Mozilla, Adobe, all part of the Bytecode Alliance, got together and gave us WASI, which is documentation for a WebAssembly system interface. And we now have lots of standalone virtual machines that can run on all sorts of different architecture. So you compile your WebAssembly code once, and you can run it literally just about anywhere. I guarantee you, if you go to any talk about WebAssembly in the cloud or read any blog about WebAssembly in the cloud, you'll see this tweet. But it is worth saying. If you don't know who Solomon Hykes is, he was one of the co-founders of Docker, one of the original architects of Docker, and he's responding to Lynn Clark, who working for Mozilla at the time and tweeting about the announcements of WASI. And Solomon's tweet is, if Wasm and WASI existed in 2008, we wouldn't have needed to have created Docker. That's how important it is. WebAssembly on the server is the future of computing. A standardized system interface was the missing link. Let's hope WASI is up to the task. Why? Because it's cross-platform, all the things we talked about before. It's cross-platform, it's high performance, it's secure, it's flexible. You can compile over 70 different languages to it. So it's a really compelling architecture for cloud technology. And actually, if you think about the history of cloud computing, we started in a scenario where in the sort of mid-90s, if you were going to deploy your application, you'd need to buy or rent a machine in the cloud, install an operating system, install the libraries and dependencies for your application, install the app itself. And if you needed another machine, you'd have had to go through exactly the same process. Obviously, that wasn't ideal, so we came up with virtual machines where we took all of the software components and separated them from the hardware components. And so you could run these virtual machines or several virtual machines on one server, which was a big improvement, but obviously each one of those virtual machines has an entire operating system built into it. So there's a lot of redundancy. There's a lot of stuff in there that we could share between those different apps that are running. And that's where we are mostly today with Docker, is that, okay, well, let's take some of the aspects of that operating system and share that in our runtime engine, be that Docker or whatever other containerization you're using. And so we still have bits of the operating system sitting inside our containers, but much less than we would have had with a virtual machine. WebAssembly is really the next natural step in that progression. And the real difference is that WebAssembly was written from the ground up to be a virtual machine. It hasn't come as an evolution of older technologies, gradually trying to separate more and more of the software from the hardware. It was written from scratch as a virtual machine. And so some of the differences between running your app in a container or running your app as a WebAssembly application, a container is an image. A container image is a full file system. Okay, you have the file system built into the container, and there's a lot of redundancy and stuff that maybe you don't need for your app within that. With WebAssembly, there is no file system unless you want one. With containers, the operating system is important. You have a Linux container or a Windows container. With WebAssembly, you compile it once, run it anywhere. Containers target specific architecture. You build your container to target x86 or ARM64 architecture, and you can only run it on that architecture. You can't take the same container and run it on any hosting service. So when you compile an app for a container, you target a specific operating system and a specific architecture. With WebAssembly, compile it once, run it anywhere. And just a bit of comparison about the two analogies. So in terms of size, containers are typically tens of meg or gigabytes in size. If you look at the Progress Enterprise Database Docker container, it's 880-something meg. Wasm or WebAssembly applications compiled 3 or 4 meg. Tiny in comparison. And so in terms of performance, for a container, it's far from native performance. You've got quite a lot of architecture that's sitting between your application and the hardware that it's running on. With WebAssembly, we saw with the Photoshop example, it's the difference between compiling it and running it directly on the machine is negligible. You can't run containers in a browser. You can with WebAssembly. In terms of portability, containers are specific to a system architecture. WebAssembly, you can run it anywhere there's a WebAssembly virtual machine. And system interaction with containers, you have the file system built into the container itself. That has some advantages. We'll talk about that in the next slide. For WebAssembly, you go through the WebAssembly system interface, so it shares the file system and everything else with other applications. In terms of security, containers are built on a lot of old architecture. You have to make sure that's all tied down. It wasn't necessarily tied down when you get it out of the box. WebAssembly was built to run inside the browser. It's sandbox and secure as standard. If you want to open anything up, if you want to have access to ports or write to disks or anything like that, you have to explicitly allow that to happen. So it's much, much easier to secure a WebAssembly application than it is to secure a containerized application. So should we be just porting everything from containers and ditching containers today and running just with WebAssembly? Well, obviously not. There are some scenarios where containers are going to be a better option. Anything with heavy input-output to the file system, to disk itself, it's likely to be more efficient running that through a container because the file system's built into the container, whereas with WebAssembly, you're going to go through the WebAssembly system interface. If you want to run existing applications with no changes, 9 times out of 10, you can't do that with WebAssembly. If you want to take your OpenEdge application and run it in Docker, you can do that today. And you probably don't have to make a great deal of code changes to do that. It's fairly easy to do it. You can't run your OpenEdge application in a WebAssembly today. And using existing deployment infrastructure, there's a lot of tooling, providers and infrastructure that's around for containers, things like Kubernetes and all the providers that support those sort of things. So arguably the ecosystem around containers is much more mature than it is around WebAssembly. And that's one reason why you might choose to stick with containers. Having said all that, if you were going to build a business application or any application from scratch today, would you choose it to be a containered or a WebAssembly application? I would argue 9 times out of 10, you're always going to choose WebAssembly, particularly if you're building anything that uses microservices, web application, event handlers, anything for edge computing. If you're not familiar with what edge computing is, it's the idea that if I have any processes that are really time critical, so for instance, self-driving vehicles where it's monitoring what's going on the road and has to react within a few milliseconds, or prescriptive maintenance in a factory where you're monitoring things within a machine that's on the factory floor. If something happens to one of those things, you need to stop the machine very, very quickly so that you don't cause more damage, or online gaming, those sort of things. So in those sort of scenarios where the server response has to be almost instantaneous, we want to put the process, that server process, as close as we can to the sensors and whatever has to respond to that process. So in a self-driving car, that might be a little bit of hardware that sits in the boot of the car, maybe. Or in a factory, it might be something that sits on the factory machine, etc. So those bits of hardware aren't necessarily the normal sort of machines that we're used to. They tend to have cut-down operating systems on there or cut-down kernels on them. And those sort of things lend themselves really well to WebAssembly. WebAssembly, because it's small, it's compact, we have all of these different virtual machines that can run on different environments, and they're really efficient. They use the hardware really efficiently. It really lends itself to using WebAssembly for those sort of scenarios. And for similar reasons, machine learning and AI, we've already said all of those Python libraries have been compiled to WebAssembly, so all of the code is available to you. But performance and the hardware that you're running on is important with machine learning and AI. We tend to want to be running on slightly different hardware that's using GPUs because it's really compute intensive and it needs to be efficient. Okay, we don't want a load of gubbins between the code that we're running and the actual hardware. We want it to really use the hardware as best it can. So for any machine learning AI scenarios, using WebAssembly is a really good option. And just a little nod back to the mention that we had about the ecosystem and how mature the ecosystem is. This is the ecosystem for WebAssembly as it sits today. So over on the left-hand side, we've got different languages. So you can, as we say, already compile 70 different languages to WebAssembly. That's some existing languages like .NET, C, C++, but there's also some new languages coming out specifically to target WebAssembly like Moonbit. So your choice of libraries and languages is enormous. In terms of runtimes, so these are not in the browser, these are standalone runtimes. Again, this changes almost daily, the number of different virtual machines that support WebAssembly. But some of the big and obvious ones, V8 is Chrome's WebAssembly compiler, runtime virtual machine that has been taken out of the browser and you can run independently. Wasm 3, Wasm Edge. There's a whole host of ones that will support different architectures and environments that you could run it in. Application frameworks, so again, some existing application frameworks like Visual Studio Code will support developing in WebAssembly, but we've got some new ones like Spin, and the examples I'll show you connecting to web services, WebAssembly web services with OpenEdge will use Spin and Fermyon. We talked a little bit about edge metals, so cut down operating systems like Flatcar or kernel builders like Unicraft support WebAssembly, so you can run your WebAssembly on those edge bare metal machines. AI and machine learning we've talked about as well. The libraries are supported and the architectures that run them will run WebAssembly virtual machines. Embedded functions is an interesting one. So this is the idea of, well, look, if we have this sort of portable, efficient virtual machine that we can run anywhere, why don't we try putting it inside some different applications and allowing people to extend functionality of different applications. So for instance, SQLite, stick it in a database so people can have user-defined functions inside a database. You can write code to manipulate the data or respond to something, create a trigger, do whatever you want to do based on things that are happening inside the database. Or Nginx, one of the most ubiquitous web servers these days. You can, and the same is true for Apache actually now, you can compile plugins for Nginx or Apache and run them directly inside. So in the same way that we're used to people putting plugins into web servers using Java virtual machines, what we do with Progress, you can now do that with WebAssembly. They've got virtual machines built into these web servers. And then tooling, these are the different compilers that are available. There's, again, a growing number of compilers supporting all sorts of different languages, compiling to WebAssembly. Emscriptum, which was the one we talked about right at the beginning that originally compiled to JavaScript, now compiles to WebAssembly, is really the de facto if you're compiling C, C++ code to WebAssembly. And it does an increasingly good job of taking any old C, C++ code and compiling it to WebAssembly. If there's any interactions with the system, operating system, it will convert those to WebAssembly system interface calls. So the amount of effort you have to go through to take existing code bases and get them running within WebAssembly, it's getting easier every single day. Down the bottom is a load of things just sort of around deployment. In orchestration management, things like Docker and Kubernetes now support WebAssembly, so you can have a WebAssembly Docker container, which is a lot smaller, slimmer than your Linux container or your Windows container, and you can run your applications inside that. There's hosted platforms, platform as a service, so Cosmonic, Fastly, Fermyon. I'll show you an example using Fermyon from OpenEdge later on. Decentralized platform, so blockchain, people are integrating WebAssembly virtual machines inside blockchain technology to allow people to, similar to the embedded functions, to add functionality to that architecture. And then we have some debugging and observability tools to allow us to debug WebAssembly stuff that's happening in the cloud. So already quite a huge ecosystem that's available in the WebAssembly world, and it's growing. I'll tell you, I did a similar slide for this for a talk a couple of years ago, and it was less than half the size. It is expanding at a phenomenal rate, and actually it's exponential the more companies get involved. To date, there's been just shy of $60 billion of funding within the WebAssembly ecosystem, and I think that's growing year on year. One last thing before we get on to showing some examples of how we can use it from OpenEdge. One last thing I want to mention is the WebAssembly component model. So Bytecode Alliance are telling us that by next year we will have the definitions for this component model. The idea is that you can define your own components and libraries in whatever language you want to use. And the component model will give us an interface definition. So it tells us how to define interfaces between different component models. If you think of it like the .NET Common Language Runtime for Wasm, so whereas in .NET you could write something in C#. So for instance, Infragistics can build a data grid in C#, and then you can use it in any other language. So you could use it in ABL because it sits on top of the .NET language, .NET Common Language Runtime, CLR. It's the same idea for WebAssembly. So we can have component libraries like NuGet or NPM, where you could just download a component library to talk to large language models, for instance, if you want, and include that in your application. Doesn't matter what language you're writing your code in, doesn't matter what language that component library was written in, they'll work neatly together. Or it could be a data grid like Infragistics or anything like that that you want to put into your user interface. I think this is the last real key building block that just makes WebAssembly a really compelling environment for whatever it is we want to build in our software. Okay, so all of that's great, but I haven't talked about OpenEdge at all yet, really. How can we use these technologies from OpenEdge? Well, today there's two choices, really. You can build a web-native user interface for OpenEdge using WebAssembly, talking to Progress backend, and you can also extend OpenEdge using Wasm microservices, and I'll give you a couple of examples of both. So looking at building a user interface using WebAssembly, well, the obvious choice would be to use Blazor. Blazor's .NET based. Lots of Progress developers are already familiar with .NET through using ABL for .NET or using .NET directly themselves. Progress have open client technology, which allows us to build assemblies that you can easily build a library, a component library that exposes your Progress ABL on the back end. If you've not used it before, basically there's a little tool called ProxyGen. You import a load of .ps into ProxyGen or classes, Progress classes into ProxyGen, all of the code that's sitting on your app server, and it builds you a .NET or a Java assembly that you can then call those through the app server. So it builds the object model. It does a lot of the scaffolding between the client application and the back end. And ideally, it'd be great to use this from a Blazor front end, for instance. So we could build a .NET front end in the web that's going to compile to WebAssembly. One of the precursors for using Blazor is it has to be .NET Core, so that's .NET 5 and above. From, I think, 12.2, so, ProxyGen supported .NET 5, certainly with 12.7, it supports .NET 6. So there's no reason why it shouldn't work. And if I... So basically, I want to expose this little Progress procedure to my WebAssembly front end. So I use ProxyGen. I'm not going to go into too much detail because, spoiler alert, this doesn't actually work. So I build my ProxyGen. It gives me some DLLs that I can embed into my, if I open my Blazor application. It builds me some DLLs that I can just embed in here, and I can then, and the great advantage is it gives me strongly named types and all those sort of things. And then I built, I'll show you, I have an example that does work, and I'll show you that in a bit more detail. But I built a little page where we can try and connect to our Progress using Open Client. Unfortunately, it doesn't work. And the reason it doesn't work is that the Open Client proxies are dependent on Web Client, which is .NET's older HTTP client technology. It was replaced years ago. They now have HTTP client, which is asynchronous. In fact, in .NET 6, Web Client has actually been deprecated, so we shouldn't really be using it anymore, and it doesn't work in Blazor. If you are interested in building a web UI using Blazor and WebAssembly, 2 years ago I posted on the Progress Ideas website just suggesting that it'd be quite an easy change just to make ProxyGen use the different assemblies rather for the HTTP clients. It is for future consideration on the Progress Ideas website. If you're interested in use it, go and give them a poke, put a message on that post. It shouldn't be more than a couple of days' work, really, to get that working, and it would make life so much easier building a Blazor WebAssembly front end. So, unfortunately, we can't use OpenClient today, but what you can do, of course, is use just a standard web interface for our Progress applications. So to do that, a REST interface for a business application makes a lot of sense, and thankfully Progress gives us some nice, easy wizards that we can use from Developer Studio just to build those services. So you, first of all, need to build an ABL service. Very easily done. It's a wizard. You have to enter 2 or 3 things, basically the name of your service, what you want to call it. We need to build a REST app. Again, it's a very quick wizard that you can run through. And then for each of the data sets that you want to manage through your REST interface, we want to build a web handler. And again, it's a wizard. You point to the data that you want to send backwards and forwards. It spits out a load of code for you. So if we go and have a look at what I've got on the back end. So I was just going to build a little interface for employees in departments coming out of Sports 2000. So when you run through the wizard, it scaffolds all of this stuff for you. You've just got to put in the code to actually populate the temp tables and spit it out. So basically, I've got a very simple bit of code that takes the departments out of the Sports 2000 database, fills a data set with it. I then convert that data set to a JSON object, and then write that back out to my web handler. And I've just done that very simply for employees and for departments. Same idea. So just a few lines of code for each. Everything else was built by those 3 wizards that Progress provide us with. And then in .NET, I have, if I stop this running. So the first thing that I did was I created a web handler class. So this is the class that encapsulates the connectivity to my Progress application server on the back end. It's dead simple. It's just an HTTP client. It's just making web requests to the back end. Obviously, if this was going to go into a production application, I'd want to put some authentication on there and all that sort of stuff. But this, just as a simple example, this is just making calls. So I've got basically the constructor for the class there, and you just pass in the address of my Progress application server, and then I've got a couple of very simple methods that just get the data sets that come back. What comes back is a JSON object. So to be able to use it at my end, because I don't have open client stuff, I have to define that object model myself. So I've just defined simple classes with a property for each of the fields in my in those 2 data sets. I've added some functionality to give me the full name, total days left for holidays, and the age. And then building a page. So my list employees page, there's actually a little bit of code behind it, but it's insignificant. I create one of my objects that we've just looked at, and I pass in the address to my app server, and then I just pull the 2 data sets out. So really simple, few lines of code. And then the page itself, again, this is the full page. This is all the code that's in there. At the top, I say if employees is null, then we must be loading. And then I've got a drop-down list. I've got a for each on my departments and just an item. So I can select a particular department if we want. And then a little bit further down, I've got a Wasm component, which is just a data grid. And you can see on this line here, all I've done is apply my department data set to it and filtered it if you've got the drop-down list. And if we run that, and I go to list employees, there we can see all of our employees. So I've got a nice functional grid. The Wasm grids are free. You can select your data set and limit it down, and we can see we've got those little calculations, so the sick days left, etc. So a nice looking user interface. It took, I don't know, less than an hour from start to finish, back end and front end, to build all that stuff. So really quick to architect this stuff. It's nice and efficient. You can do, lots of processing in the client. You can put lots of business logic in that model if you want in the client. As as a way of developing user interfaces, I would thoroughly recommend it. We've spent the last 2 years building Blazor front ends, having done JavaScript front ends before that, and I can tell you it's much more productive than we ever were with JavaScript front ends. Okay, so all of that stuff, you know, you might have heard before. We talked about a couple of years ago. What has changed in the last couple of years is the sort of things that we can do with WebAssembly on the back end now. So microservices are a great use case for WebAssembly. So for instance, if you wanted to add usage logging to your application, maybe you've got your application installed on thousands of different sites, but you don't have any real sight of who's using it, what pages they're going into, and all of those sort of things. Adding that sort of architecture using the Progress application, putting it in the database and making sure you don't slow everything down is quite a lot of work. To do that sort of stuff using WebAssembly microservices is cheap, efficient, quick, and easy to do. And I'll show you how to do that. Or if you want to interact with large language models, you want to start using some of the AI technology that's out there, using WebAssembly is a great way of getting hold of that sort of technology and incorporating it within your OpenEdge application really quickly and really easily. What I've done is I've gone to Fermion, which is one of the platform as a service providers, and just picked out a couple of examples that they've got on their website just to show how you can do it. To get started with this stuff is pretty easy. You know, I did this specifically for the talk. Took me 4 or 5 hours to get a couple of good examples running from scratch. So if we wanted that use case, that first use case where we were saying, okay, we want to just have a see who's using the application, what screens they're going into, whatever other information that we want to store. Well, a good way of doing that is to use a key value store. So a key value store, you've got a key and whatever values you want to store against that key. So the first thing that I did was just go to here and then just download the source code for that example from GitHub. You don't have to run this stuff in the cloud straight away. You can run it locally on your machine first. To do that, you just download Spin, stick it in a directory, and put it in your path environmental variable. That's it. So it doesn't take long to do that. When I downloaded that example, it gave me if we go into so here's the spin key value stuff. There's only a couple of things that you actually change in here. This TOML file is basically your .ini file for your little spin application. So you just set up things like what port you're going to and those sort of things in there. So nice and easy to change. And then there's the source code for this example. I'm using TypeScript just because that's the language that the example was written in. If you're not familiar with TypeScript, you could use JavaScript or any of the other languages supported in WebAssembly. So this is dead simple, really. We've got a request coming in. If it's a post request, all I'm doing is storing the value that's in the body of the request using the URL. So the value that's in the URL of the request. And if I want to get the value back out, I do the opposite. So I use the URL as my key value. I try and get the value out of the database, the key value store. And if it's there, that's what I return. Otherwise, I just return a 404. And then from Progress, I've got a nice simple screen. So I've just got a couple of buttons. I've got a license key, which is what I'm going to use as the key in my key value store. And then I've got a value that I'm going to send to it. So when I click on update log, it will run through this code. So I just build up an HTTP client to make the request. I build a JSON object, and I'm putting the current date time and the username, and then I'm posting that using my key into the database, and then doing the opposite, dragging it out. I'm making the request using the license key. I'm building my JSON object from what comes back, and then I'm just placing a message in. So if I click on license log, we're storing the value, and I click on get last usage, and we can see the date and the person. So very simple, but what's neat about this is you can deploy that to Fermion. Just type in one line, spin.deploy, that's it, and it's deployed, and that will scale from no users to hundreds of thousands to millions of users without you doing anything. And it's cheap. From, I think it's 0 to 100,000 requests a month, doesn't cost anything. Beyond that, up to 2 million requests is $20 a month. So it's really quick, easy to build these sort of things, to deploy them, and to have them enormously scalable. The second example is a little bit more in depth. So the second example, again, going to Fermion's website. They've got an example here, a sentiment analysis API. So the idea of this is I can write a sentence, it will stick it through Llama 2, which is the Meta Open large language model, and it will tell us whether that's a positive sentence, neutral, or negative sentence. So sentiment analysis. So you could use this if people were commenting on, I don't know, making a booking, and you could sort them by positive, neutral, negative comments against your bookings. You could obviously use it to build a chatbot, same sort of thing. This is just one use case example. So again, I've just gone to GitHub. I've downloaded my my example. To run it locally, you have to actually download the Llama large language model as well, which is about 6.5 gig. So it can take a little while. The source code in this, there's a little bit more to it, but it's not huge. So we can see at the top here, the first thing that I've got is a prompt, and this is how you use these large language models. This is largely how it's a completely different way of thinking about coding. So in here, what we're going to send to the large language model is you are a bot that generates sentiment analysis responses. Respond with a single positive, negative, or neutral, and follow the pattern of the following examples. So user, hi, my name is Bob. Bot, that's neutral. User, hi, I'm happy today. Bot, that's positive, etc. And then we've got a little bit of text that we're going to replace when we actually make the request. And if you look further down, we're using a key value store here again. It's actually quite expensive in terms of compute power to make a request to these large language models, so you want to avoid it if you can. So we've got a key value store. If somebody enters exactly the same value before, and we've already stuck it through the large language model, let's just pick it out the key value store. That costs us virtually nothing. So I look it up in the key value store first. If it's not there, then a little bit further down, here's where we actually make the request. So LLM infer, and I'm passing in the model, and then I'm just replacing the sentence that the user's entered into our prompt that we were sending, and that's what's getting sent to the large language model. So to start that up, if I just go to the directory that it's installed in and spin up, actually starts it running on my machine. And then in progress, I've got a very similar program. So it's just got a button, it's got a text box that I can enter whatever the sentiment is, and then I build up my request. So I'm asking the request to my sentiment analysis. I'm passing in the payload, which is just a little JSON object that's just got the sentence in it. And then if it comes back, I'm just saying the sentiment is such and such. If I run that now, so we've got, I don't know if you can read that, it says, well, this is very nice indeed. Press the button and it comes back instantly saying the sentiment is positive. If I look at what's actually going on at this point, it found that in the key value store. That's the default value. So it's just pulling that straight back. If I put something we've not used before, so maybe pug challenge is great, for instance, and press that, takes a little bit longer. Actually, running this on my machine takes about 3 minutes to go through the large language model. If you deploy it up to Fermion, because it's running on GPU technology and it's specifically designed to run on that, and it's got a lot more power than my laptop has, takes about 2-3 seconds to come back with a response. I'll leave it running. We can see that it will actually eventually give us a response. So again, I mean, putting that example together took me, obviously I'm taking someone else's example and just integrating it with Progress, but it was very easy to do. But, you can start playing with large language models within half an hour. You can have it running from Progress and, change it for your use case. Have an explore of what happens when you give it different prompts and want to do different things. So if you want sort of microservices for Progress, or you want AI or machine learning functionality for your Progress applications, then adopting WebAssembly as a technology is a really good idea, and easy and cheap to do. Thinking forward, what could we do with WebAssembly in the OpenEdge community? And I mean, obviously I was sat listening to John's talk earlier this morning, thinking about this, thinking about trying to attract new developers to OpenEdge, thinking about trying to future-proof OpenEdge as an environment. In my opinion, the thing Progress should be looking at is compiling the ABL to WebAssembly. In terms of, is it possible? Well, the ABL's written in C. The mature compilers, we talked about mscripten before. It does a really good job of taking any C++ code and compiling it to WebAssembly already. Unreal was compiled to JavaScript in 4 days using that tool set, and it's much more mature now, certainly in terms of its interaction with the operating system. Microsoft have ported the whole of .NET to WebAssembly. Everything that you can think about in .NET, all of the different interactions are all available in WebAssembly with .NET 8. They're available in standalone virtual machines as well as with the browser. Other database engines like SQLite, Postgres are now running within WebAssembly. So those databases themselves running inside WebAssembly. So those bits of technology have been ported. Connectors for other databases like MySQL. I think that's probably that. Like MySQL have been ported as well. So it's certainly possible. There's no doubt it is definitely possible. I suspect there's a significant amount of work in it, but not a huge amount. Why would we want to? Well, this is just looking at Progress's own page advertising OpenEdge. And read what it says. So supercharged enterprise app development, build dynamic multi-language apps with secure deployment across any platform, device, type, and cloud. And just put that in the context of everything we talked about at the start of this presentation. OpenEdge technology today is natively compiled executables with many dependencies. You've got Java and JVMs for your Progress application server in there. The Docker image just for the database itself is 889 meg. If we could port some, maybe not all, but some of that architecture over to WebAssembly, just think about what you could have in the OpenEdge community. So you could have something like Blazor, something, a cross between Blazor and WebAssembly. So doing the same sort of thing that we're doing with .NET, you could do with Progress, with the ABL. You could write web speed like code, but it's actually running in the browser. Really efficient, really fast. On the back end, we could have Progress application servers that ran inside Nginx or Apache without the need for a Java virtual machine. They would be significantly quicker, much quicker to start up, much quicker in terms of their processing power. Why put it inside a web server if we don't need all of that gubbins? Those two examples that we've just looked at, they have a web interface. There's no web server involved with them. There's none of all that extra architecture. Whether or not you port the database engine itself to WebAssembly, I think is a moot point. Maybe not to begin with. There's a lot of file input and output, so maybe it doesn't make sense. It doesn't matter though. That really what we want is all of the architecture stack that sits above that. And again, going back to if we're going to attract new people to the OpenEdge community, opening up, having WebAssembly, having the ABL as one of those languages that people can look up and say, oh, okay, what is ABL? Why would I want to use that? You know, small, lightweight, portable, secure. I guarantee you, your application would be faster, much, much faster than it is now. Thank you. Any questions?
I'm just wondering, if you have a language like Go, for example, which compiles into its own runtime package with it, how are you going to debug or profile such an application once in Wasm?
So, I mean, I haven't developed with Go, for instance, but if you do it in .NET, your debugger attaches to the WebAssembly runtime itself, so you can debug it in exactly the same way you would debug any code. So it compiles, when you compile it, I presume it produces a debug attachment that you can run alongside that. So in .NET at the moment, if you're running your C#, you can put a breakpoint, you press run, it opens up in the browser. When it gets to that point in the browser, it stops on the breakpoint in Visual Studio or VS Code.
It's the profiling I'm concerned about, because that's a lot different, because you have two different architectures basically colliding, whether you're using a virtual machine type of language like Java, like C#
Yeah.
or CLR, or you have Go, for example, which has its own sort of runtime compiled into it.
Yeah. But there is an interface that the WebAssembly virtual machines expose to whatever tooling you're using, development tooling you're using. So if that development tooling has debuggers built into it, they can attach to the WebAssembly runtime and stop at whatever breakpoints you want. Yeah, it's certainly, I mean, developing with Blazor, we found early on debugging was the hard point. Initially, we were debugging in the browser. So you would run your code in the browser, and the C# would be appearing in the development tools, in the dev tools in the browser, and you could stop on it. And it worked, but it was quite difficult to see values, within variables and those sort of things. Today, if you run it, you put your debug in Visual Studio, and it stops at the breakpoint in Visual Studio, and you can see everything. You can see all the properties and variables, so it works very well. Yeah. Any other questions? Yeah, Peter. Yeah, well, it's a web app. So our WebAssembly front end, for instance, runs as a web app, so you can stick it on the desktop, but it is just a website. So yeah, and it runs smoothly. Runs all of the browsers on your mobile devices have WebAssembly virtual machines built into them. So yeah, I mean, I could hold up my phone and show it to you, but I don't have it attached to my screen. But yeah, it's it has all of the advantages of building a web app using JavaScript. That it runs natively in the browser, so it works beautifully as a mobile application as well. And if you just support web apps in your mobile site, you don't need to download an app. You can just have the icon on your desktop, and it'll just take you straight to the web page. Anyone else? No. Well, thank you very much. I hope it was useful.
Question: what's Pazoui?